Welcome to the 6th Arachne tutorial. In this video, we'll be looking at checks. Checks are used throughout Arachne as conditions, but most often to start and end an action. You can find the check classes in Arachne on the locations shown on screen. These are divided into basic, analog, and digital checks. They're prefixed with CH for identification. Basic checks include checks that are always true or always false, for example. Analog checks are based on numeric readings, while digital checks are based on Boolean ones. For the purposes of demonstration, we'll create some check instances in command list to look at what they do. Normally, you just create check instances in the constructor of whatever was using them. The first check is the false check. This check will never have its requirement fulfilled, and so will never return true. Unsurprisingly, there's also a true check, which will always return true. The Q check is a little more interesting, in that it will return true as soon as there are more actions to be performed. We'll look at this in more detail once we cover actions. Then there's the time check, which will return true after a certain amount of time has elapsed since the first time that it was checked. Now on to the analog checks, the first of which is the gettable number check. Many things in Arachne will return a number. For example, motors will return the speed that they're traveling at. The check then uses this to form a condition. For example, the check on screen will return true once the wrist motor on the arm is traveling at 80% power. We do this by first putting in the required value, in this case 0.8, and then the gettable number that we want to use. We can invert this by putting a false on the end. This check will return true as soon as the speed of the motor is less than 0.8. We can also determine whether it uses the absolute value. Here, adding true on the end means that the condition will be true once the motor is between minus 0.8 speed and positive 0.8 speed. That's all for gettable numbers. Now on to numeric senses. These are quite similar to gettable numbers, with a few extra features. The first three here are just like the gettable numbers above. The first will return true once the potentiometer sensor passes a value of 2.71. The second will once the encoder goes below a value of 2.71. Finally, the third will return true once the analog sensor is between minus 2.71 and positive 2.71. The fourth demonstrates the final option for a numeric sensor check. Adding a third true or false value will determine whether the sensor being checked is reset before starting the check. This could be useful, for instance, in setting a gyro to 0 before making a turn. Finally, there are the digital checks. The button action can be used to check if a button is pressed. This one, for instance, would return true if the second driver button was pressed. If we change the second value to false instead of true, it would return true when it wasn't pressed. The gettable Boolean check is a lot like the gettable number check we looked at before. Many robot components will have Boolean values. For example, a switch might tell you whether it's pressed or not. The check requirements will be fulfilled if the value of the gettable Boolean you gave it is the same as the second Boolean value you put in the constructor. In this case, that would be the digital input named DI on the sensors subsystem. As the second value is false, the check requirements will be fulfilled if the digital input has a value of false. For a basic switch, this would mean that it wasn't pressed. We can also use it to check the position of a solenoid, like so. In this case, if the solenoid controlling the claw on the arm is extended, then the check requirements will be fulfilled. You can also use the same check if you wanted to for a button. However, you might lose any functionality that we add in the future to the button check. The action and command checks are a little bit more complicated. To demonstrate them, we're going to break up the components of the drive command that we created in an earlier tutorial. The action in this case is an instance of the drive action that we created. We can then create a command setup as we did above with that action. Finally, we can create a command from that command setup. We'll use this for the command check. If those three lines don't look familiar, don't worry, we'll be covering them in the next tutorial. We just need them there to demonstrate the functionality of the action and command checks. Using the action that we've created, we can create a check whose requirements will be fulfilled once the action has finished running. The command check functions in exactly the same way for a command. Note that we're passing in the command base instance, not the command setup instance. If you try to give it the command setup instance, it's going to give you an error and won't work. That covers all of the checks. In the next video, we'll be using these check conditions to start and end actions.